Next problem in first come first serve scheduling algorithm, that is, consider the following set of processes with the length of CPU burst given in milliseconds. Here the processes and its burst time is given, that is process 1 burst time is 10, process 2 burst time is 1, process 3 burst time is 2, process 4 burst time is 1, process 5 burst time is 5. Okay, the processes are assumed to have arrived in the order like this: process 1, process 2, process 3, process 4, process 5, and all the arrived at clock time 0 milliseconds. Okay, we need to assume that all these processes arrived at clock time 0, and order of arrival is process 1, process 2, process 3, process 4, process 5. Draw the Gantt chart that illustrates the expression of these processes using first come first serve scheduling. What is the turnaround time? What is the waiting time of each process? And what is the average waiting time and average turnaround time? We need to find it here. Okay, first we'll draw the Gantt chart. And in the question, it is given that all the process arrived at clock time 0, but the order of arrival is process 1 first arrived to the waiting queue. Next, after that, process 2 arrived, then process 3 arrived, process 4, and process 5. Okay, so first in the waiting queue, which process arrived? That is process 1. So process 1 will get CPU will be allotted to process 1. Okay, and what is the burst time for the process 1? It is 10 milliseconds. So process 1 will be executed by the CPU for 10 milliseconds. At 10 milliseconds, process 1 will complete its execution. Okay, then CPU will become free. Next, who is in the ready queue? After process 1, process 2 is in the ready queue. And what is its burst time? It is 1 millisecond. So CPU will be allotted to P2, process P2. Okay, its burst time is 1 millisecond, and it will CPU will execute the process P2 for, until clock time 11 milliseconds. That is, process P2 will get CPU at 10 milliseconds clock time, and it needs to complete its execution 1 millisecond because its burst time is 1 millisecond. So process P2 will complete its execution at clock time 11 milliseconds. Okay, at 11 milliseconds, CPU will become again free. So already in the ready queue, there are other processes. That is the process after process 2, process 3 is in the queue. So process 3 will get CPU now. Okay, its process 3's burst time is 2 milliseconds. Okay, and process 3 will get CPU will be allotted to process 3 at clock time 11 milliseconds, and its burst time is 2 milliseconds. Okay, to complete its execution, it will take 11 plus 2, it is 13 milliseconds. Process 3 will complete its execution by the CPU. Okay, at 13 milliseconds, CPU will become again free. Now, next process which is in the ready queue is P4. Okay, P4's burst time is 1 millisecond. CPU will be get allotted to the process 4, and it will execute the process 4 until clock time 14 milliseconds, because P4's burst time is 1 millisecond. P4 will get allotted CPU at 13 milliseconds clock time. So P4 will complete its execution at clock time 14 milliseconds. Okay, at clock time 14 milliseconds, CPU will become again free. Now we have another process in the ready queue, that is P5. Okay, P5 will get CPU allotted for process 5, and P5's burst time is 5 milliseconds. P5 will get allotted CPU at clock time 14 milliseconds, plus its burst time is 5 milliseconds. 14 plus 5, it is 19 milliseconds. Process 5 will complete its execution by the CPU. Okay, like this we need to draw the Gantt chart. Okay, by seeing the Gantt chart, we can find the waiting time. How to find the waiting time? Waiting time is nothing but allotted time minus its arrival time. Okay, here all the processes are arrived at clock time 0 milliseconds. In the question, it is given that all the processes arrived at the clock time 0 milliseconds. Okay, so waiting time is allotted time minus arrival time. For process 1's allotted time is how much it is? 0 milliseconds. Process 1 is allotted. Okay, for process 1, CPU is allotted at 0 milliseconds. So waiting time is allotted time minus arrival time. Okay, allotted time is 0 minus arrival time is 0. Okay, so the waiting time is 0 milliseconds. Next, process 2 allotted time is 10 milliseconds and its arrival time is 0 milliseconds. 10 minus 0, it is 10 is the waiting time for the process 2. Next, process 3 allotted time is 11 milliseconds. Okay, minus its arrival time is 0 milliseconds. 11 minus 0, it is 11 milliseconds. Process 3's arrival time, waiting time is 11 milliseconds. Next, process 4's allotted time is 13 milliseconds. Its arrival time is 0 milliseconds. 13 minus 0, it is 13 milliseconds is the waiting time for process 4. Okay. Next, process 5 allotted time is 14 milliseconds. Its arrival time is 0 milliseconds. 14 minus 0, it is 14 is the waiting time for process 5. Okay, now we know all the process waiting time. Now we will be calculating the average waiting time. How to find the average waiting time? Sum of all the processes waiting time divided by total number of processes. Here process 1's waiting time is 0 plus process 2 waiting time is 10 plus process 3's waiting time is 11 plus process 4's waiting time is 13 plus process 5's waiting time is 14. Okay, 0 plus 10 plus 11 plus 13 plus 14 divided by total number of processes. We have 5 processes. Okay, so divided by 5, we will get 9.6 milliseconds is the average waiting time. Okay, now we'll see how to find the turnaround time. To find the turnaround time for the specific process, turnaround time is sum of the burst time and its waiting time is the turnaround time of that process. Okay, now process 1's turnaround time will be calculated by summing the process 1's burst time and process 1's waiting time. What is the process 1's burst time? Process 1's burst time is 10 milliseconds and its waiting time is 0 milliseconds. 10 plus 0, it is 10. 10 is the turnaround time for process 1. Next, process 2's burst time is 1 millisecond. Okay, and process 2's waiting time is 10 milliseconds. 1 plus 10, it is 11 milliseconds is the turnaround time for process 2. Next, process 3 burst time is 2 milliseconds and waiting time is 11 milliseconds. 2 plus 11 is the turnaround time for the process 3. 2 plus 11, that is 13 milliseconds is the turnaround time for process 3. Okay, next process 4. Process 4's burst time is 1 millisecond and its waiting time is 13 milliseconds. Okay, 1 plus 13 is the turnaround time for the process 4. Okay, 1 plus 13 is 14 milliseconds. 14 milliseconds is the turnaround time for the process 4. Okay, next process 5's burst time is 5 milliseconds and process 5's waiting time is 14 milliseconds. 5 plus 14 is the turnaround time for the process 5's turnaround time. Okay, 5 plus 14 is 19 milliseconds. 19 milliseconds is the process 5's turnaround time. Okay, after finding the turnaround time, we need to find the average turnaround time. Average turnaround time is nothing but sum of all the turnaround time divided by total number of processes. Okay, process 1's turnaround time is 10 plus process 2's turnaround time is 11 plus process 3's turnaround time is 13 plus process 4's turnaround time is 14 plus process 5's turnaround time is 19. Whole divided by total number of processes is 5 processes. So we will get average turnaround time is 13.54 milliseconds. Okay, 13.4 milliseconds is the average turnaround time. Okay, we'll see another problem. This is also an example problem for first come first serve scheduling. Here the following example calculate the average turnaround time and average waiting time using first come first serve scheduling. Here the processes are given like this: process 1, process 2, process 3, and process 4. And arrival times also are given. Process 1 arrived at clock time 0 milliseconds. Process 2 arrived at 1 millisecond. Process 3 arrived at 2 millisecond. Process 4 arrived at 3 millisecond. And its burst times are given here like this. Process 1's burst time is 8 millisecond. Process 2's burst time is 4 millisecond. Process 3's burst time is 9 millisecond. Process 4's burst time is 5 milliseconds. Okay. Here in the question, they have given the arrival time, burst time for the processes. Okay. Here we have the 4 processes. Okay. Now we'll represent in the Gantt chart. These processes will represent the Gantt chart by using first come first serve schedule. Okay. Here the which process will arrive to the ready queue first? It is process 1. Process 1's arrival time is 0 milliseconds. Okay. So the process which arrives first, it will get the CPU by using first come first serve scheduling. Okay. Now process 1 will get, CPU will be allotted to the process 1. Okay. So its arrival time is 0 millisecond. At 0 milliseconds, CPU will be allotted for the process 1. Process 1's burst time is how much? 8 milliseconds. Okay. Process 1 will be executed by the CPU for 8 milliseconds. At 8 milliseconds, again CPU will be free. Okay. Next process, by that time in the ready queue, we have process 1, process 2, process 3, process 4. Process 2 arrived at clock time 1 millisecond. Process 3 arrived at clock time 2 millisecond. Process 4 arrived at clock time 3 milliseconds. Okay, these 3 processes are already in the ready queue. First process 2 arrived, then process 3 arrived, then process 4 arrived. Okay, now CPU is free at clock time 8 milliseconds. Process 2 will get CPU at clock time 8 milliseconds and its burst time is 4 milliseconds. Okay, 8 plus 4, 12 milliseconds. Process 2 will complete its execution. Okay, again at 12 milliseconds, CPU will become free. Next in the ready queue, the process 3 is there in the ready queue. Process 3 will get allotted CPU. Okay, and process 3's burst time is 9 milliseconds. 12 plus 9, it is 21 milliseconds. At 21 milliseconds, process 3 completes its execution. CPU will become free at 21 milliseconds. Okay, at 21 milliseconds, we have in the ready queue process 4. Okay, what is the burst time for the process 4? It is 5 milliseconds. 21 plus 5, it is 26 milliseconds. At 26 milliseconds, process 4 will complete its execution. Understood, right? Like this, we need to draw the Gantt chart. Now we need to find waiting time. How to find the waiting time? Waiting time is nothing but process allotted CPU minus its arrival time. Okay. For process 1, CPU allotted at what time? It is 0, clock time 0 milliseconds. 0 minus process 1's arrival time. Arrival time is 0. Okay. 0 minus 0. 0 is the waiting time for process 1. Next for process 2. Process 2's CPU allotted time is 8 milliseconds. Okay. Minus its arrival time. Okay. Process 2's arrival time is 1 milliseconds. 8 minus 1, it is 7 milliseconds is the waiting time for process 2. Next, process 3's allotted time is 12 milliseconds and its arrival time is 2 milliseconds. 12 minus 2, it is 10 milliseconds is the waiting time for process 3. Okay, 10 milliseconds. Next, for process 4, allotted time is 21 milliseconds. Okay, and its arrival time is 3 milliseconds. 21 minus 3, that is 18 milliseconds is the waiting time for process 4. Understood how to calculate the waiting time? Waiting time is allotted time minus its arrival time. We will get the waiting time. Now we'll find average waiting time. Average waiting time is nothing but sum of all the processes waiting time divided by total number of processes. Okay, here the process 1's waiting time is 0 plus process 2 waiting time is 7 plus process 3's waiting time is 10 plus process 4's waiting time is 18 divided by 4. 4 is the total number of processes. Okay, we'll get average waiting time is 8.75 milliseconds. Understood this? Now we'll find the turnaround time. Turnaround time, we can calculate it. It is sum of turnaround time is sum of burst time plus waiting time. Sum of burst time plus waiting time, we will get the turnaround time. Okay, here for the process one's burst time is how much? Process one's burst time is 8 milliseconds and process one's waiting time is 0 milliseconds. 8 plus 0, it is 8 milliseconds is the turnaround time for process 1. And process 2's burst time is 4 milliseconds. Process 2's waiting time is 7 milliseconds. 4 plus 7, it is 11 milliseconds is the turnaround time for process 2. Okay. Next, process 3's burst time is 9 milliseconds plus its waiting time is, process 3's waiting time is 10 milliseconds. Okay, 9 plus 10, it is 17 milliseconds is the turnaround time for process 3. Next, process 4's burst time is 5 milliseconds plus its waiting time is 18 milliseconds. 5 plus 18 will get 23 milliseconds is the turnaround time for process 4. Okay, after finding the turnaround time, we need to find the average turnaround time. Average turnaround time formula is sum of all the processes turnaround time divided by total number of processes. Okay, turnaround time for the process 1 is 8 plus turnaround time for the process 2 is 11 plus turnaround time for the process 3 is 17 plus, 19. Process 3's turnaround time is 19 plus process 4's turnaround time is 23 divided by total number of processes. Total number of processes, we have 4 processes. Okay, 8 plus 11 plus 19 plus 23 divided by 4, we will get 15.25 milliseconds is the average turnaround time. Okay, like this we need to solve. Now we will find another problem. The following processes arrive for execution at time indicated below. Okay, that is process 1 and its arrival time, burst time is given here. Here the processes, process 1, process 2, process 3, process 4. 4 processes. Arrival time of process 1 is 0. Arrival time of process 2 is 1.5. Arrival time of process 3 is 3 milliseconds. Arrival time of process 4 is 3 milliseconds. And burst time for the process 1 is 1.5. Burst time for the process 2 is 3 milliseconds. Burst time for the process 3 is 1 millisecond. Burst time for the process 4 is 7.5 milliseconds. Okay. Here in this problem, arrival times are given, burst times are given, and processes are given. Draw the Gantt chart and calculate the average waiting time by using FCFS scheduling. First come, first serve scheduling algorithm. Okay, first we need to draw the Gantt chart. Here, the process 1 arrived at clock time 0. At clock time 0, CPU is free. So, process 1 will be allocated CPU. Okay, and it will start, process 1 will start executing by the CPU, and its burst time is 1.5 milliseconds. Okay, process 1 will start execution at clock time 0 milliseconds. It needs to complete execution 1.5 milliseconds. So process 1 will be executed by the CPU until clock time 1.5 milliseconds. Okay. Next, process 2 will arrive to the CPU at clock time 1.5 milliseconds. Okay. And its burst time is 3 milliseconds. At 1.5 milliseconds, CPU is free. So CPU will be allocated to the process 2. Okay. And process 2's burst time is 3 milliseconds. Process 2 will start execution by the CPU at clock time 1.5 milliseconds, and it needs to complete its execution 3 milliseconds. So process 2 will be executed by the CPU 1.5, it will start executing 2.5, 3.5, 4.5. Okay, 3 milliseconds it will executed by the CPU. At 4.5, process 2 will complete its execution. The CPU will become free again. Okay. By that time, at clock time 3 milliseconds, process 3 arrived to the ready queue. Okay. That time CPU was executing the process 2. Okay. And after completion of process 2's execution, at clock time 4.5 milliseconds, CPU become free, and the CPU will be allotted to process P3, and its burst time is 1 milliseconds. Okay. At 4.5 milliseconds, CPU will be allotted to the process 3, and it needs 1 millisecond to complete its execution. That is 4.5 milliseconds to 5.5 milliseconds. Process 3 will be executed by the CPU. Again, at 5.5 milliseconds, CPU will be free. Okay, here at clock time 3 milliseconds, we have another process called process P4 also waiting in the waiting queue. Here, both the process P3 and process P4 arrived at clock time 3 milliseconds, but order of arrival is process 3 came first to the ready queue, then process 4 came to the ready queue. Okay, so first process 3 completed its execution at clock time 5.5 milliseconds. At 5.5 milliseconds, CPU is free. CPU will be allocated to process 4. Process 4's burst time is 7.5 milliseconds. Okay, it will come, process 4 will starts executing at 5.5 milliseconds. Okay, and it will be executed for till 7.5 milliseconds. 5.5 plus 7.5, it is 13 milliseconds. At 13 milliseconds clock time, P4 will complete its execution by the CPU. Understood this? Like this, we need to draw the Gantt chart. Once if you draw the Gantt chart, we need to find the waiting time. Okay, if you find the waiting time of each processor, we can find the average waiting time. Okay, so first we'll find waiting time for the process 1. How to find the waiting time for the process 1? Waiting time is allotted time minus its arrival time. Here, process 1's allotted time is 0 milliseconds minus process 1's arrival time is 0. 0 minus 0, 0 is the waiting time for the process 1. Okay. Next, process 2's allotted time is 1.5 minus process 2's arrival time is 1.5. Okay, 1.5 minus 1.5, it is 0. 0 is the waiting time for process 2. Okay, next process 3's allotted time is 4.5 milliseconds. Okay, allotted time is 4.5 milliseconds, but its arrival time is 3 milliseconds. 4.5 minus 3 milliseconds, we will get 1.5 milliseconds. Okay, 1.5 milliseconds is the waiting time for process 3. Okay. Next, process 4 allotted time is 5.5 milliseconds and process 4's arrival time is 3 milliseconds. Okay, 5.5 minus 3 milliseconds, it is 2.5 milliseconds is the waiting time for process 4. Okay, it is 2.5 is the waiting time for process 4. Okay, the average waiting time is sum of all the processors waiting time divided by total number of processes. Okay, here the process 1's waiting time is how much? 0 plus process 2's waiting time is how much? 0. Process 3's waiting time is how much? 1.5 plus process 4's waiting time is 2.5. Okay, sum of 0 plus 1.5 plus 2.5 divided by total number of processes. Total number of processes are 4 processes. We will get 1 millisecond is the average waiting time. Now we'll find the turnaround time. How to find the turnaround time? Turnaround time is sum of process burst time plus its waiting time. Okay, first process 1's burst time is 1.5 millisecond plus process 1's waiting time is 0 milliseconds. 1.5 plus 0, it is 1.5. Okay, turnaround time for the process 1 is 1.5 plus 0. It is 1.5 is the turnaround time for process 1. Okay. Next, process 2's burst time is 3 milliseconds and its waiting time is 0 milliseconds. 3 plus 0, it is 3 milliseconds is the turnaround time for process 2. Okay. Next, process 3's burst time is 1 millisecond. Waiting time is 1.5 millisecond. 1 plus 1.5, it is 2.5 milliseconds is the turnaround time for process 3. P3's turnaround time is 2.5. Okay. Next, process 4's burst time is 7.5. 7.5 plus its waiting time is 2.5. Okay, 7.5 plus 2.5, it is 10 milliseconds. Okay, 10 milliseconds is the waiting time for, 10 milliseconds is the turnaround time for process 4. Then average turnaround time can be calculated like this. 1.5 process 1's turnaround time plus process 1's turnaround time is 1.5 plus process 2's turnaround time is 3 milliseconds plus process 3's turnaround time is 2.5 milliseconds plus process 4's turnaround time is 10 milliseconds divided by number of processes, that is 4 processes. We'll get 4.75 milliseconds is the average turnaround time for the processes. Like this, we can solve the problems by using first come, first serve scheduling algorithm.